Hello everyone, welcome back to this another video on Google Earth Engine. I'm Lalit from Map Painters. Today we are going to learn how to use the CHIRPS dataset of precipitation for your study area. So I have divided this tutorial into 5 parts. First, we are going to add the boundary of our interest. Then we'll import the CHIRPS data and do some filtering. Then we are going to convert this CHIRPS data which is available in pendant to per year. Then we are going to export this data in Drive, and in the step 6 we are going to create a line chart of our study area that shows the trend of precipitation. First of all, let's add boundary of our interest. To do that, I have the district of Nepal available in my cloud assets. I'm going to import this to my script. I'm giving it Nepal. So in Nepal there are 77 districts. From that district, I'm going to select a specific district, which is Dailik. So for that, I'm going to give a variable AY. The name of our save file is Nepal, which has 77 district dot filter. From that, I'm going to filter Dailik. So Dailik is under this dist underscore en column. Okay, that's how you filter specific district from your whole data. So I'm going to add this to my layer. To do that, just write add layer. Name of our layer is AOI, and we are giving it color of red. Okay, and name is, let's run this. It's showing some error. Oh, I forgot to write equals to here. Now it will run. As you can see, our layer is already added in this map, but it's not displaying at the center because the default center of Google Earth Engine is in United States. To keep our to bring our map in center, we have to write one another line of code, that is map.center object. Okay, center object, the object that we want to center is AOI, and the zoom level, let's keep it 8. This one again. Now you can see that our map is in the center of our map section. In our step 2, we are going to filter CHIRPS data. First of all, let's import the CHIRPS dataset. In the source panel, just write CHIRPS. So here are 3 data. Let's learn about the first data. This is the CHIRPS data of 0.05 resolutions available from 1981 to the today's date. And if you see here, the unit is per day. It contains the data of precipitation in per day. Let's explore the pendant dataset. You can see this is also the resolution of 0.05 degree, that is 5566 meter. It's available in the unit per pendant, that is 5 days. So we are going to use this data for this video. From the collection snippet, select the copy this snippet and let's paste here. It is a image collection. Now we want to select the band that we want to work with. So in the CHIRPS, if you see, it has the a band name Precipitation. So let me copy this and insert the select. We are going to paste this band name, and now we want to filter this for a specific date. So I'm going to use filter date. The date we are going to use is for the year 2024 0101 January 1 to 2025 January 1. So in the filter date, if you want to filter the data for 12 months, the last part is exclusive, so you have to give 2025 January 1st. Okay, let's run this. So no error, that means our code is correct. So when to convert this data from pendant for per pendant to per year. Okay, to do that, let's make a variable annual preci is equal to shapes dot reduce. So we are going to use reducer here because the whole CHIRPS dataset is a very large dataset. So we are going to mean rainfall for the year 2024. So here we are going to use EE reducer dot mean. So it gives the mean value of the year of the rainfall in our specific area for the year 2024. So next we are going to make a variable annual rainfall is equal to annual precipitation dot, and we are going to multiply it by 73 because in 1 year there are 73 pendants. So we are going to use this. Okay, the name is ANNUAL sorry, missed R. Now let's run this. After that, we are going to add this annual precipitation rainfall data in our map section. For that, simply write add layer, and our variable name is annual rainfall. Okay, we're not going to give any that visualization parameter 8, and we are going to give the name rainfall. Okay, it's loading here. It might take some time. So what is happening here is it is displaying the global data set. To display data of our region of interest, we have to use clip function here, and we are clipping it by AOI because our region of interest is AOI. So let's run it again. Now you see it's displaying only at AOI, but it is displaying in white color. Okay, so to give any visualization parameter, we can go to the settings here. So you can see this is the setting button. Click here, then you will get this type of visualization parameters. So in the custom, let's give it the stage of 2 standard deviation, and let's click apply. So once we apply that, our color of our map is changed. This is black and white because we haven't provided any palette. So let's give some type of palettes. If the rainfall is very low, we are going to give it this type of sky color. If it is very high, then we'll provide this type of color. So we are going to give this 3 palette. Click apply. So you see the palette that is very light, it has very low rainfall, and the palette that has very bright color, it receives high rainfall in this area. From that, you can also try to stage in 98%. Let's click that and check your result. So there are different methods to visualize your data. So this is one of it, but you can also manually add the visualization parameter here. So for that, use bar beige. Okay, so minimum value is 0 here, and maximum value is let's see from here what is the maximum value. So it's 1072, but we are not going to give this because at the 95% stress, the minimum value is 857 and maximum value is 1194. Let's use this value. Okay, so minimum value is this much and maximum value is this much. Okay, so there's a very famous website called Color Viewer where you can select the color that are suitable for your analysis. Today I'm going to select this single U color. You can also select multi U color, and for the class the default is 3, but you can change the class. For example, if you want to use 4 classes of color, you can do that from here. Then in the export section, just go to export, and you can get the permalink or for the CSS or for JavaScript. So we are going to use this JavaScript because Google Earth Engine use the JavaScript. So let me copy this, come back to my script, and let me paste this here. Okay, so once I do that, and instead of this curly braces, we are going to add beige here, and let's run it again. So now you can see that our visualization has been successful here. So the fourth step is to export this map to drive. So to export your map, just write export dot and press enter and space together. So once you do that, you'll get a lot of options like export classifier, image maps. So we are going to export the image. So I'm selecting this image, and inside the image it gives us options. You want to export image or image to assets or cloud storage or drive. So in my case, I'm going to export this in my Google Drive. So I'm selecting this, and again if you press Ctrl and space bar together, so you'll get this type of description inside. So let me make it list. Okay, so we need image, then we need description, then we need folder. We don't need these two. Then region, then we are going to use it scale. We don't need CRS or CRS transform. Let me remove this, and we need max pixel. So I'm going to remove these other files. Okay, so let me close this process. Okay, so in the image, let's see what is the name of our image. So it's annual rainfall. Okay, just write annual rainfall. So description, keep some description. For example, I'm going to write this is the rainfall of the lake. So folder means the folder where you want to save this data. So in my case, it's the name of my folder in Google Drive is Logic GE. So region is our area of interest, AOI. So scale, you see that the scale of this data is 5566 meter. So I'm going to use this default, but if you want to change the scale, you can do that. And the max pixel, I'm going to give 1e13, and let's run this. So once you run this, this task will glow up, and if you see here, you can click on this run button. So it will give this type of taskbar here. So one thing I forgot to mention is you can't give space in your uh, task name. So I'm going to give underscore rainfall here, and I'm going to change this as well. And if you click run, so it will take some time, and it will eventually export your data to the drive. So next thing we are going to do is to create a line chart. To create line chart, we have a function name with UI. Then we are going to use chart, and we are going to chart an image and by series. So inside parameter, so in the image collection, so see here we have to provide image collection, not image. So the name of our image collection is this chips. Let me copy this. So region, we know that the region of our interest is AOI. Then we are going to use the reducer. The name of our reducer we used previously is EE dot reducer dot mean. We are using the mean reducer scale, but we can provide 5566 meter. We are skipping this X properties. Okay, and now if we print chart, you see in the console the chart is not defined. Okay, so we forgot to give the variable. The variable name is chart. Okay, now if you run this, it will work. So it's generating the chart. It might take some time. Chart looks like this. So if you do that, you can see in the February there is low rainfall, and between the June and October there is high rainfall, and in the December the rainfall is very low. So in this way you can generate chart. You can download it as CSV or download it as SVG or PNG. Thank you for watching this video, and I'll see you in the next one. Bye bye.